All right, so let's continue on with our discussion of conditional statements and truth values. So here are the 4 total conditional statements and how they're related to each other. Okay, so we have our conditional, right? If P, then Q, right? And I typically label the conditional as CD for conditional. CD conditional. Then we have what's called the converse. The converse is where you reverse the hypothesis and the conclusion of the conditional. So it's very much related to the conditional, it's just the opposite order. I use CV for converse, so CD for conditional, CV for converse, and you'll see if Q then P. Just reverse the order of the hypothesis and the conclusion. Now, negation is just an idea here. And when you negate something, it's when you take the opposite of the meaning. So this tilde means not P, not P. So typically it means including the word not in your statement. So now by negating, we create 2 more conditional statements. One's called the inverse. The inverse is obtained by negating both the hypothesis and the conclusion of the conditional. So it's in the same order as the conditional. It just is with not and not in your statements. The inverse and the contrapositive are related because the contrapositive is then the reverse of the inverse. It's where you negate both, but then the original hypothesis comes second and the original conclusion comes first. And again, for inverse, I use IV for inverse, and for contrapositive, I use CP. So again, that's my shorthand for when we do these. So example 3, we're going to write and evaluate the truth value of a converse. So it's going to write, it says write, determine the truth value of the converse of the conditional statement. If you play the trumpet, then you play a brass instrument. So this is a conditional. Here's the if. So you play a trumpet is our hypothesis. Then you play a brass instrument is the conclusion. We need to write the converse, which is where you switch that. So we're going to say if. We're going to read the conclusion first. You play a brass instrument. Then you play the trumpet. Okay, so the question is this converse true? Right? So this is our converse. Well, if you play a brass instrument, do you necessarily have to play the trumpet? No. So you could play a brass instrument, that would be true, but you don't necessarily have to play the trumpet. You could play the trombone, you could play the tuba, right? So there's a bunch of different brass instruments that are not trumpets. Tuba, you can play the trombone. So therefore, this converse with a true hypothesis and false conclusion, this converse itself is going to be false. There you go. All right, next example here. It says, write and evaluate the truth value of an inverse and a contrapositive. Write and determine the truth value of the inverse and contrapositive of this conditional. If 2 whole numbers are both even, then their sum is even. All right. So, one thing I want to do. So we're going to do the inverse and contrapositive. I need to add a word. So, and they did both. Okay. Sorry, they did that. That word's important. Okay, so this is our original hypothesis. This is our original conclusion. So to write the inverse, we're going to keep the order the same, but just negate them. So we're going to say if 2 whole numbers are not both even, then their sum is not even. Okay, well, let's take a look at an example here, right? So let's take a look at some examples. So if 2 whole numbers are not both even, not both even. So, for instance, 5 and 11 are not both even, so they must be odd, right? Well, 5 plus 11 is going to be 16. That's an even. It says they have to be an odd even. So I was able to come up with an example where you had two numbers that were both not even, but then the uh, sum was even. So again, this is one of those true leading to false. That's the only situation where your conditional is false. Your conditional statement is false. Okay, now let's do the contrapositive. So now we take this inverse and switch the order. So I'll do it in blue. Let's do it in blue. Contrapositive. So if, so now notice here where it says there, what does there refer to? Well, there refers to the two whole numbers. So what we're going to do is we're going to ad lib some words. So we're going to say if the sum of two whole numbers is not even. So notice this. I left the two whole numbers idea in the original, the hypothesis, the opening phrase. Then they, and then you'll say then they. So there's that they represent the two whole numbers. Then they are not both even. So what I'm looking for here is I'm looking for a sum of two whole numbers that is not even. So let's do a sum of 17. So what would two numbers be that add up to 17? Well, that would be 9 and 8. 9 and 8, 17. Both of them are not even, so this checks out. What if my sum was 25? Two numbers that could add would be 5 and 20. Both of them are not even, right? That gets you 25, so that's good. Let's do one more. So the sum would be 33. Two numbers to get 33 would be 12 and 21. They're both not even. That equals 30, so that's good. So I am thinking that yes, you can have a sum of two whole numbers that is not even, and it was going to result in two numbers that are both not even. And true leading to true would lead to a true conditional. So that's a true statement. So there's our investigation of kind of inverse and contrapositives. Okay. Next. Okay. Last idea here is what's called a biconditional. So when we talk about a biconditional, notice this prefix bi, bi. A biconditional is where you combine the conditional and converse. So you typically leave the order of the conditional, and now you put this double arrow. This double arrow means this statement works both ways. And again, it's pronounced P if and only if Q. Now, this is very important. So when P and Q have the same truth value, the biconditional is true. So notice here, when P and Q have the same truth value, the biconditional is true. So be aware of that. And again, it's this idea because they go both ways. Notice that, when you go this way, that creates a false conditional. When you go this way, that creates a false converse. So you'll see that that's when those truth values don't help out. Okay, so again, these two rows are what we're looking at. All right, so let's take a look at some biconditionals here. Let's see if we can make some statements with using combinations of conditionals. Write and evaluate a biconditional. A marine biologist writes this conditional: if a seahorse gives birth, then it is male. Since it is true that among seahorses only males can become pregnant and give birth, should the marine biologist state this as a biconditional in a paper she is writing? Explain. So this is the conditional, right? We have our conditional. Seahorse gives birth is the hypothesis. It is male is the conclusion. So now I'm going to write what's called the converse, because you need to make sure that the conditional and converse have the same truth value. So the conditional is true. So what's the converse going to say? Well, we're going to write it out. So if, now I'm not going to put if a seahorse is a male, So notice I left the seahorse in the original hypothesis. Then it. So now the pronoun still is in the conclusion. Then it gives birth. So the question is that going to be always true? Well, yes, a seahorse can be a male, right? But does every seahorse have to give birth? I don't think so. So this is actually a true hypothesis leading to a false conclusion. That is one of the situations where your statement is false. And because the conditional is true and the converse is false, this would lead to no biconditional. So again, this statement is false because a male seahorse might not be pregnant, might not be pregnant. So because your conditional is false, there is no biconditional to write. Okay, last one here. I know these writing statements can get kind of long. Sorry about that. Identify the conditionals in a biconditional. What are the two conditionals implied by this biconditional? A triangle is equilateral if and only if it has three congruent sides. So these are your magic words, if and only if. So this is your P, your hypothesis. This is your Q, your conclusion. So for the conditional, we're going to write if a triangle is equilateral, then it has three congruent sides. Easy peasy, right? Follow the same order as the biconditional. Just take out the if and only if and put if and then. So now for your converse, we're going to take this conditional and switch it around. So if a triangle, now notice I'm going to put if, I'm going to not going to put it, I'm going to put if a triangle has three congruent sides. So I'm putting that main idea first, has three congruent sides. Then it is equilateral. So again, I left the triangle there, I left the it there, but then the main idea is switched positions. And there you go. And there's how you break apart a biconditional into two conditionals, the conditional and the converse. All right, a lot of sentence writing, I know. Thanks for watching. We'll see you next time.